So this is not meant to be a comprehensive tutorial by any means, but it's just playing around with the digital multimeter in TinkerCAD. So first of all, I'm inserting a 9-volt battery in there, and then I'm bringing the multimeter in there as well. And I'll just make sure that the multimeter is in volt mode. I'm connecting up the positive of the multimeter to the positive of the 9-volt battery and checking by starting the simulation. You can see that it measures 9 volts. Just move it the other side and then it still measures 9 volts. But if we want to import another battery in there, we'll see if we can connect them in series or parallel. So first of all, let's try it in parallel. So connect them on top of each other like this and connect the positive terminals and the negative terminals together. We can see that we're still reading 9 volts, which is interesting. The voltages are not added. The voltages just stay the same at 9 volts. In this case, we're going to connect it up in series. So we're going to connect the two batteries together from positive to negative, and we're going to measure the voltage across the two of them together and see that it's 18 volts. How about if we put a third battery in there? So you can see where this is going. If we put the third battery in series in this way, then we should expect to see 3 times 9 volts, which is 27 volts. That's exactly what we do see. So this is somebody being foolish, but that you can watch on YouTube to see what happens if you were potentially to connect 244 of these batteries all together. And obviously do not try this at home. But you can play in TinkerCAD very safely. So let's put a 1.5 volt battery here. And then we would expect it to be 1.5 volts. We don't really need to check that, but put a second one in there and a third. And then we'll connect these in series. So we're connecting up the negative and positive terminals of the batteries. So we should expect 3 times 1.5 volts is 4.5 volts. So let's install a 9-volt battery here, but let's connect it a little bit differently. Let's connect it so that we're connecting the positive of the 9-volt battery to the negative side of the multimeter and the negative side to the negative side of the rest of the other batteries in series. And notice how that it goes to minus 4.5 volts. An interesting thing to consider here is, are we charging those other batteries potentially? Or because there's just a multimeter there, it's not really a circuit where lots of current is flowing, any charging current is flowing. In this case, we'll put a coin battery in there. It's easier to connect this one in series, so we can actually see that we get the 4.5 volts plus 3 volts. Now we're going to install some resistors, and we're going to measure the resistance across those resistors. So we've got one here that's 1 kilo ohms, and we're just going to connect the terminals. Doesn't really matter which way around it's connected. Notice how we got 0 volts here. We have to actually change it so we're measuring resistance. And when we start the simulation, now we actually get the 1 kilo ohms. Put a second resistor in there. The second resistor is also 1 kilo ohms. And we connect the two of them together in series, and we measure 2 kilo ohms across the two of them. We can play around with these while the simulation's going, so we can change them to be 2 and 3 kilo ohms each, and when we add those together we get 5 kilo ohms. In this case we're going to connect them in parallel rather than in series, and what would you expect here if they were both 1 kilo ohm? So interestingly, it's half. So you might like to consider why this is with reference to the formulas for calculating the resistance in a circuit, and also play around with some other values of resistance there.